And now I have the honor to call Dr. John Howard, Director of the Safe and Sound, to present the awards today. Thank you.
Thank you very much. It's always a pleasure to be at these meetings. You all seem to have so much fun, and you always seem to meet at near important bodies of water in the United States. I noticed that the last time I was here, I was in St. Petersburg, Florida, which was a very nice place, and San Diego is actually my hometown, so it's a thrill for me to be here. I just want to, before we present the awards, to thank each and every one of you for the work that you do to keep all of our ears functioning at the level that God gave us, for research, for people who do interventions and practice. Your role in the American workplace is extremely important, and I hope that you realize that it is much appreciated. So, we at NIOSH and the National Hearing Conservation Association are very pleased, again, as Thais said, to jointly announce the recipients of the 2016 Safe and Sound Excellence in Hearing Loss Prevention Awards, honoring those who have shown extraordinary commitment to the prevention of noise-induced hearing loss through innovative practices, policies, and unique advances in research in the field. The first Safe and Sound Excellence in Hearing Loss Prevention Award goes to the manufacturing sector. The environmental health and safety staff and workers at 3M Alexandria in Minnesota are the recipients. Starting in November 2011, 3M Alexandria received corporate support to reduce noise exposures and the need for their workers to be enrolled in hearing conservation programs throughout their facility. Noise exposures were so successfully reduced, 12 to 14 dBA across 24 different areas and departments, that 199 out of 203 employees were no longer required to be included in the 3M Alexandria Hearing Conservation Program. Their initiatives are recognized for the all-inclusive and systematic, statistically driven noise exposure assessments, cost-effective noise reduction projects, the documentation of cost and noise reduction results, and the implementation of Buy Quiet principles. In addition, 3M Alexandria has maintained a high-quality audiometric testing and a hearing protection selection and fit program for those few employees who remain exposed to noise. 3M Alexandria's success story demonstrates that noise control is desirable, it's achievable, and most importantly, it's economical in both the short and the long term. So it's a great pleasure for me to invite Matt Van Watermeulen to receive a Safe and Sound Excellence in Hearing Loss Prevention Award.
Thank you very much. The committee has asked us to go through and give a short presentation on what our project was. And Carl is in the back there, will be available afterwards if you have any questions on the methodologies and things that we went through for this project. If you're familiar with 3M, 3M is a worldwide company, over 80,000 employees, and in our little site in Minnesota, we have about 350 full-time, part-time temp worker employees that work at that site. At this particular site, we have manufacturing capabilities around abrasives. So we make belts, discs, all kinds of different materials that are used to grind and polish metals, wood, plastics, and things in other manufacturing industries. We're primarily a industrial manufacturer, so very few of our products actually go to retail. They're made for other industries to make their products. Essentially, it's just gluing rocks on paper. That's all it is. It's a pretty simple process. So this is our project team. I mentioned Carl is in the back to help with questions afterwards if you have any. The project team, this is just kind of a snapshot, was primarily maintenance, engineers, myself, supervision, but also the operators. I mean, this is, like I said, just a snapshot, but there were dozens more that participated in this project to help get it pushed through and help build all the different noise enclosures, reduce all the noise in the different areas of the plant. So kind of how the project started. Back in 2011, I had just started at that site, and our manufacturing director at that time came into the site on their quarterly visit and asked us, I'm going to give you $500,000 what's going to take to get this plant out of hearing conservation. The reason for that was he was seeing quite a few standard threshold shifts and noise-induced hearing loss cases come through that division. Way too many. So we started looking at it. The plant manager came to me and said, here's what he's telling us. Let's see what we can do. So what we did is we came up with 27 different plant areas to target, and it seemed at that time a huge task to take on. So we had to come up with different ways to make it easy to manage. All right? So we used a lot of different lean principles, and I'll go into that in a little bit. But the big thing here was we had upfront management commitment straight away. If we didn't have that, this project would have failed to begin with. So that's one thing, if you're going to take anything away from this, upfront management commitment is a must. One of the things in terms of project rationale, going through a lot of the different areas of those 27 were blanketed into hearing conservation. The actual dosimetry, 8-hour dosimetry, was not done on some of those different employees in those areas to establish a need to whether or not it would need to be hearing conservation. So an SLM measurement was taken at 85 decibels, which is what we follow for standard or occupational exposure limit to noise. And if it was at 85 for a second, it was put in. So not the right way to do it, but not necessarily a bad way to go about it either. It's better to be safe than sorry, right? So the need for implementing hearing conservation was overlooked by just using that SLM measurement. So we had to go back in a lot of those areas and take 8-hour samples to make sure or see where we're at, basically. A couple of things we did in terms of evaluating each of the areas. 27 areas is a lot of work to undertake. So we determined priority for evaluation. We looked at noise level in the area, how many workers were exposed to that noise, whether or not it was hearing conservation area, estimated cost and removal, and all that played into what we call a cause and effect analysis chart. And that cause and effect analysis, all it does is simply risk rank where do we sit with targeting that area in terms of hearing conservation removal. All of those areas go into what we call an A3. It's simply called an A3 because it's printed on A3 paper. That's it. There's no special thing with that. It's just printed on A3 paper. But all it is it's a lean management tool that's used to help manage and track projects to closure. We assembled a project team in each area to tackle each individual of those 27 areas. And then at sub A3, what that did is it just helped us manage what individual tasks do we need to do to get those areas out of hearing conservation. And assign accountability to the engineers, the supervisors, and the operators in the different areas for tasks assigned to get that work done, basically. We had to use personal dosimetry to validate each area according to what we have as company requirements to get those employees out of hearing conservation, implemented controls if needed, and then removed if justified. Like I said, management commitment on this project was completely needed and inherent for success. The division leadership came up with the challenge. They challenged us as a plant to remove basically the entire site from hearing conservation. Plant leadership now brought that down to the EHS department, and then we gathered our resources in terms of plant engineering, production, and then we also use our corporate and division IH contacts as well as occupational medicine as resources to help provide compliance support, data interpretation, that kind of thing, in moving forward with either a removal or we need to keep them in and reduce even more. So a couple examples. These are just to kind of show the differences in cost and the differences in the types of controls that we put in place. This is one of our drum slitting disc converting areas. Employees cannot be validated at a 12-hour shift duration. They did pull at a 8 and 12 or 8 and 10-hour shift. What we did is we do the measurements for whatever shift length the operators would work, and then we calculated the 8, 10, and 12-hour DWA equivalents for those areas, and then removed based off of those numbers validated. Before controls were put in, we were about 82 to 85 decibels in this area on an 8-hour TWA. After controls, a simple noise enclosure box with a vent on the top side was between 72 and 76. About a $600 cost, and that was strictly maintenance cost. One of our making areas, a couple different enclosures and controls we put in this area. We saw a lot of brake squeaking. On a lot of our equipment, we have basically the same type of brakes or drum brakes that you would have on your car. And these things trying to stop a 4,000-pound roll moving tend to squeal a lot. So we actually went through the plant, and this is one example here where we sized the brake to be appropriate for that size of roll. And then noise enclosures over ovens to protect from dust collectors, fan motors, that kind of thing. We even moved some dust collectors to different areas of the plant where employees weren't located, up on the roof or outside, that kind of thing. And then another area of our plant where we had approximately $60,000 in cost, where we fixed air leaks, muffler replacements, new blower fans. We had an engineer that came up with a silencer for sandblasting equipment, similar to that, that's on the silencer like on a pistol, that dampened the noise but still created enough velocity where we could have product performance and process performance. MAC valves are actuated valves that turn on and off air as it's needed in the plant, so not only a sound savings, but an energy savings. And then acoustical enclosures around steering units, motors, that kind of thing. The thing we ran into most on those is the heat escape on those types of enclosures, making sure that we're not boxing something in and then causing the motor to overheat, and then you got to buy a new motor, and that really makes people mad, so you don't really want to do that. So the results, out of the 27 areas, every single one of them we've reduced noise in. We've eliminated 92% of those areas. We've got about 2 areas left. All in all, right around 950 8-hour samples on 61 different jobs. We removed, or are in the process of removing, 195, 199 employees from hearing conservation. We have 4 employees left, and I just checked with my occupational health nurse last week, and yes, we still have 4 in the program. So, the noise controls were implemented below budget estimates. We had, like I said in the beginning, about a $500,000 upfront budget. All in all, we came in about $250,000. So it was well below budget. So it just kind of goes to show that noise control is not expensive, as expensive as people think it is. And then employees feel better when they're working. It's evident in people's attitudes around these different areas. I get comments all the time from employees, "Thank you for doing this. It's so much better working in these areas." So this is kind of a snapshot and overview of our plant. The shaded area there, if you can see it, is areas where hearing conservation was required. 199 employees in hearing conservation there, and we have 2 small areas now that remain. We removed 11 hearing conservation areas at 0 cost. Most of those areas where either a SLM measurement was taken and we could validate those areas out based on 8-hour dosimetry measurements, or we took and just rearranged equipment in an area to keep employees away from the noisy parts or pieces of the equipment. We're targeting to remove the rest of our plant by the end of this year. We're sharing best practices with 3M, you folks here at NHCA, NIOSH. And then just to kind of show you some of the different stats that we have in terms of threshold shifts, we had 0 threshold shifts in 2013, 1 exit in 2014 and 0 in 2015, and I'm expecting again 0 this year again. Moving into the future, a couple things we're going to be doing, looking at the different areas that were validated out or removed. We have basically a scale on what they validate out of. It's a categorized scale, and that categorized scale is based on the where that occupational exposure limit sits. And so those at the 3, basically 75 to 100% of the OEL, less than that, are going to be targeted first for further noise reduction. Any new equipment that comes into our plant, we've got a couple different new equipment installations coming into the plant now, have to be a noise-free install, meaning that it has to come into the plant at 78 decibels or less. And we've been successful at that with a large maker installation here in the last year, and then another couple pieces of converting equipment in the next few months. And then again, we're continuing to teach the methodology to other 3M plants and then other industry professionals. Noise control is the way to go. In my opinion, it's a lot easier to manage in terms of hearing conservation, hearing protection programs. But again, that top management commitment is an absolute must. If you don't have that, the project will not succeed. Develop a structured plan, set in stone timeline is needed. We set in stone and we said, in that 3-year time period, we are going to remove these areas, and these areas. And we stuck to that plan and achieved that goal and ended up getting those areas out. Be critical of the process removal. One of the things that we do is in terms of sample analysis is we validate those results. So we look at the likelihood that we'll ever go over again and make sure that we hit those numbers where we want them before we take those areas out of hearing conservation. So be critical of that. Removal from hearing conservation is not the end point. That continuous noise or the annoying noises, employees kind of turn into a better than an SLM sometimes when it comes to measuring noise or finding trouble spots in a plant. They'll tell you exactly right where that annoying sound is coming from. Fix it. It's not that hard to do. And then focus on hearing conservation. Like I said, the annoying noise, or focus on hearing conservations, but not just those hearing conservations. Focus on the annoying noises as well. And then, again, it's hearing conservation, noise control is not an expensive process. We found that out. We've proven that. But some areas do take some cost as well. So you got to kind of think about that as well. Significance of the award for us, it validates and recognizes our efforts at 3M Alexandria and 3M. I know a lot of other sites now are getting the expectation to take their areas out of hearing conservation because of things that we've done in Alexandria. And it shows that, hey, we're a leader in EHS innovation, noise control, and those types of initiatives. Again, if you have any questions, I'll be around. Carl will be here to field those questions after the awards ceremony. So, thank you.
Congratulations again. Our next Safe and Sound Innovation Award is being presented to Professor John Casali and the Auditory Systems Laboratory from Virginia Tech. John Casali is the John Grado Professor in the Department of Industrial and Systems Engineering at Virginia Tech and the Director of the Auditory Systems Laboratory. He is also past President of the National Hearing Conservation Association 2009 NHCA Outstanding Hearing Conservationist Recipient and co-chair of the 1995 NCHA NIOSH Joint Hearing Conservation Conference. John Casali and Virginia Tech are receiving the Safe and Sound Innovation Award in hearing loss prevention for their pioneering, extensive, and innovative efforts in hearing protection research and auditory signal detection. The work of the Auditory Systems Laboratory is unique in that it combines human factors engineering with acoustics and audiology to solve research questions in many aspects of auditory perception and hearing health. The areas of research are broad and based on and include auditory situation awareness for military and industrial applications, improved hearing protector design and evaluation, warning signal design and effectiveness, speech communications in noise, auditory requirements for specific job duties, signal detection and noise reduction in aircraft cockpits, integration of various items of personal protective equipment and interoperability, and noise annoyance in communities. The impact of their work extends beyond hearing loss prevention into safety. Their initiatives to study the user's ability to hear, perceive, and respond to important auditory stimuli in their environments, that is, the ability to maintain auditory situation awareness, are recognized as innovative and broad-reaching and are considered critical to the improvement of hearing protection devices and the safety of their wearers. The ultimate beneficiaries of this work are primarily military personnel, but also workers in jobs which impose hazards that stem not from being able to hear important signals and communications. John Casali's example and leadership instills a culture of scientific rigor, precision, and attention to detail that contributes to practical solutions in the real world of hazardous noise exposure. It's my great pleasure to invite John to present on their innovation and receive the Safe and Sound Innovation Award.
Thank you very much. It was quite a surprise to hear from Thais Murata and Deanna Minke about being nominated for this award, and I'm very grateful to you for deciding on us in terms of innovation. I do want to say that, first becoming engaged with NHCA back in 1990 was really a fortuitous event for me because it helped to shape my career in many ways. And I found that the organization, welcomed somebody with a background that's atypical, perhaps for this group, ergonomics and human factors engineering. But I've learned so much from so many of you, and it's really been a great help to my career. With this presentation, Thais coached me and asked me to talk about the award innovation that's being recognized in particular, but also to try to go over a little bit of background about our laboratory and a little bit of prior work, prior people that were in the lab that led up to this area of research, which has been largely our focus for about 7 or 8 years. So the innovation itself, as Dr. Howard said, has to do with the measurement of auditory situation awareness, the development in particular of an objective test battery for that. And really, if we think about the individuals that are affected by hearing protection devices, where they have to maintain a sense of auditory situation awareness, we have in this set of photographs the military, law enforcement, first responders. And many times they have specialized devices on, often electronic sound transmission devices that have a pass-through circuit for signals and communications, as well as many other provisions, sometimes passive devices that also allow sound of low levels through, but then attenuate rapidly when there's an impulse. So these are the types of devices that we were primarily focused on in terms of how do they affect situation awareness. But a test battery of this type could be applied to any type of hearing protector, even the simplest passive protector. And it's interesting that one of these photographs says the word mission essential equipment, because really it's not just the equipment in terms of this type of evaluation. We can do piecemeal evaluations where we understand physical characteristics and properties of hearing protection, like the NRR, spectral attenuation, gain profiles, attack and decay curves, frequency response curves, and all of that. But until we put the device on a person and the person has to perform with the device as a system, a human-machine system, then we really don't know the outcome. We really don't know the success of the device. And to me, that's what situation awareness is about. So this is the lineup. We have a small team that worked on this particular project. On the left there, Dr. Katie is primarily our technology person. He's a patent attorney and a physicist. And Dr. Kitchell Lee works with me as a regular faculty member at Virginia Tech, manages the Auditory Systems Lab. Kitchell, would you please stand up? And Kitchell is responsible for a number of the accomplishments in development of this test that I'll be talking a little about. And you know, in academia, we are indebted to research sponsors and collaborators, and I've been blessed with a number of them. This is just a small list, but particularly for situation awareness and the drill comm test that came out of this, the DoD Hearing Center of Excellence, under the leadership of Colonel Mark Packer, funded the primary project that resulted in the test battery. We also had help from the Office of Naval Research, and that's Kurt Yankaskis's program. He's not able to be with us. And then early on, NIOSH provided support for the non-military applications, particularly in the construction environment where workers have to hear a number of signals, the most prevalent one being backup alarms. I also just wanted to say that over the years, I've had a number of research areas that have been sponsored by both corporate and government sponsors. You see some of the people there that are in the room, and in every case, you know, I've learned from the interaction, and in every case, we were asked to evaluate something or run a parametric experiment, and we were advised by these individuals to run the experiment, design it, conduct it as we saw it should be done. It was not dictated to us, and to analyze the data as we saw it should be done. Therefore, we felt we had an objective, unbiased outcome in every event. So I'm indebted to these folks for their support and for the latitude they gave us in running the experiments as we saw they should be run. A little bit about the lab. It's getting pretty old. It was founded in 1983. I hope this is not a retirement talk, but maybe it's getting close to it. If it's anything, it's a versatile facility, and we don't have a huge annual budget, but it supports several students and part of my salary in Kitchell. It's a little bit unique in that for an academic lab, our split in funding is about half and half military, government, and corporate. And we've been blessed with a number of contracts, about 108 and about 60 sponsors. So it's been pretty steady over the years, and we've got to work on some very exciting projects. In terms of educational output, roughly 2 students have graduated per year with either a master's or PhD from this program, and I've had about 53 advisees in total. Good number of publications, about 6 patents. 2 of those patents have been exploited and developed. And in terms of education, you know, which is one of our primary missions, this laboratory supports 8 different courses at Virginia Tech and about 5 workshops that we've done in NHCA and elsewhere. Now, we're not primarily a testing lab by any means. We're an R&D lab, but we do testing according to these standards. And it's just interesting when I was thinking about this. We do an occasional hearing protector NRR spectral attenuation test in that top set. But to tell you the truth, most of the testing we get asked to do is human aural non-detectability testing, stealth maintenance, devices that go on a soldier that need to be quiet, that need not to give the soldier away. So there's a lot of emphasis on that type of testing. And then the last category there would be the second one that's most prevalent. It would be testing of alarms, backup alarms and other things. So leading up to this innovation, the way we tend to think about it is that there's a systems view of tasks that we can do when listening that support our perception of things about us in our environment, since our ears are always on, they don't blink, and they're a key component to maintaining auditory situation awareness. So if we think of that in terms of systems, nothing can happen without detection. That's so fundamental. And then once we detect something, we can do higher order cognitive activities. We can decide what is that, recognize and identify it, maybe localize it in our environment, which is a complex task because we might be localizing around us in azimuth. In elevation, typically in front of us is what the ear is best at doing, and we can also try to determine speed and direction of something that may be moving toward us or away from us. And once that occurs, once we're in the ballpark in terms of our orientation, the eyes can take over and we visually orient. And then after that orientation, of course, we can evade it if it's a threat. We can target it if we need to take some action. Now, while all this is going on, perhaps we need to be communicating and multitasking, communicating with others. There may be noise that pervades the situation, and the whole thing might be exacerbated by the presence of a hearing protection device. So hearing protection clearly has an impact or potential for impact on situation awareness because there are the fundamental tasks involved in situation awareness. So the innovation, I guess, if there is one here, we tried to bring this auditory situation awareness to the attention of research inquiry. And there are a lot of implications of that for selecting hearing protection for application in critical tasks. So we've been on it about 8 years on this topic. And there's been some research outputs from that. We've had 8 contracts to deliver on. And we've experimentally demonstrated, as you'll see in a few minutes, some of the effects of hearing protectors and advanced TCAPs on situation awareness for the 2 applications of military and construction. And we have a test battery now. It's called DrillCom, just an acronym so I can remember it. And we've targeted we're kind of now going the next step to try to target critical design parameters that affect hearing protector design, that we can say, if you do this, this is what we predict you'll get in situation awareness effects. And out of that, we have 2 patents, 2 new patents. So a few years back, about 3 years ago at this conference, it was a technical paper, but maybe it sounded more like a sermon, asking for, could we as a community spend more time on situation awareness, at least 10% of the time that we spend on the NRR. And I felt that was important because of the implications of not being situation aware. There just, can be some very dangerous aspects to that. So that was a plea back then. And we had some motivations. Much of this came from you. Obviously, the VA has a tremendous expense with tinnitus being, I understand, the top expense annually, and NIHL right behind that. If people aren't going to wear their devices because they're worried about their ability to hear things, then they're going to take them off. Secondly, of course, the loss of auditory situation awareness. The effects of that can be catastrophic. Fatalities in road construction are common, often attributed not hearing an alarm and often while wearing hearing protection, certainly for the military as well. And then the third one, the military talks a lot about tactical ability, survivability, lethality. Obviously, that poses a liability to oneself as well as other members of the squad. And that comes from 2 things. If the person has a hearing loss, they may have some liability there, and or if they lose their situation awareness because they're compromised by a device, similar liability. So the contributions, hopefully, of the innovation, they'll accrue to this prevention of noise-induced hearing loss and tinnitus because the devices will ultimately be more user acceptable. And certainly if a soldier in particular, and perhaps to a less extent a worker, but many workers are in dangerous situations, if they believe that a protector is compromising them, particularly if there are life-threatening implications, tactical implications that might affect their mission, they're going to remove it. No question about that. And hopefully from this, as we learn, auditory situation awareness will be ultimately improved through better device selection and enhanced design. And there's no doubt in my mind that the manufacturers of T-caps and advanced hearing protectors want to do this. It's an iterative design process, and they need the information to improve. Beneficiary groups, obviously military personnel, emergency personnel, and civilian workers in dynamic situations, and even civilians in recreational settings that are wearing so-called hunter's ears. They're riding ATVs with hearing protection on. In our area of the country, it's legal to ride ATVs on many streets now. And if you have a hearing protector on, with the ATV noise, you may not be able to hear traffic sounds, etc. So there are many situations where this situation awareness is at issue. The final test battery that we developed includes these components, obviously, of DrillCom. And tomorrow, Dr. Lee will talk about some of the detection task results. And I'm not going to really talk about any results, but this is the battery and the components that are included. The communications components is for the pass-through communication where two individuals are close to each other, and we're measuring that performance. Obviously, if you have a test battery, you've got to have instrumentation, protocol, analysis techniques, etc. And this is conducted in a hemianechoic room. That's a university classroom, a low-noise classroom. It's been treated. And what you have, of course, in the center is a ring of speakers to do the azimuth localization that also presents the detection cues as well as the recognition identification cues. In front of the subject who's seated at the center is the array of speakers for elevation, a localization in frontal elevation. To the right, the silver duct is a noise attenuating duct with a big fan at the end of it so we can introduce wind noise to the picture, because obviously, in most cases, these people are outdoors, so we need to include that in on the test. And the walls are treated to provide a hemianechoic facility. So one example, just one of the tasks that I haven't really talked about here before is the recognition and identification task, and I just wanted to say a word about the conditions. So what we have included in the test as it now exists is to do a discrimination task. Why is that important? Because on these pass-through devices, particularly the electronic ones, they all have a certain frequency response. They're microphoning a signal on the outside, it's passed through an amplifier, has a certain pass band, certain frequency response into a loudspeaker on the inside. So when that happens, it leaves its imprint on the signal or leaves its imprint on the communications. And in doing so, it can certainly affect your ability to tell one sound from another. So that's why it's a discrimination task. Signal-to-noise ratios of -10, 0, +10. These are always presented in triads. You're given all three signals as a subject, and then you have to pick the position of a stated target signal. You're trained as to what these signals are in advance. So one of the really tough triads is the footstep sound. So footsteps in snow, leaves, and gravel, very similar from temporal characteristic, very similar from spectral characteristic, somewhat different in timbre. And you have to be able to perceive that timbre through the device in order to tell, are they in snow, leaves, or gravel? This was one of the tougher ones. One that's not quite as tough is the second one, gun cocking sounds, AK-47 bolt-action rifle. If the frequency response is lacking and it's high in response, this task is going to be compromised, or if there's too much attenuation, if it's a passive device. So, we have a series of triads. There are 36 different sounds that are used in this type of task. We have run an experiment. It's a proof of concept experiment. It was aimed at looking at the sensitivity of this DrillCom to between device differences and always device versus open ear. Each subject serves as their own control. And secondly, to ascertain whether the test battery was diagnostic. In other words, could it discern a device's ability to do detection versus recognition, identification, etc. A different score on each task element, and not just a score as to accuracy of response in degrees of localization or number of correct recognitions, but also speed of response, because that's critical. We got statistical significance with a small subject sample of 10, and Kitchell-Lee was the experimenter on all of this. The devices that were looked at in the initial study are these. The top 3 are currently deployed devices, the Contact 3 being a muff configuration, the Invisio X50 in the ear, currently deployed TCAPs with the Army. The Honeywell Quiet Pro Plus is the Marines product. The Etymotic EB15LE, that is the law enforcement version of the LE sound transmission earplug. And then I believe it's the 5th generation of combat arms in its open position, plus the open ear for comparison. So what are the results? The results are in a final report that we just recently submitted to the DoD Hearing Center of Excellence. And release of the report is a DoD decision. You know, it'll be determined how sensitive is the data, can it be released. But overall, and we'll talk about what we are allowed to talk about in this, but overall the DrillCom test battery, that's the issue here. It was statistically significant, showed sensitivity to auditory situation awareness performance differences between devices in the open ear, and it was very diagnostic. A device could do very well on detection, but fall down on localization, for instance. And that might be important for selecting a device for a particular mission or a particular MOS. I thought I'd say a little bit about cost. You know, one of the things that was an objective here, and it was instilled in us by the Hearing Center of Excellence, is try to be as objective as you can in your test battery. Try to make it as efficient as possible in terms of time to get the data, and instrument it as inexpensively as possible, but still, you know, we want it to maintain accuracy, good calibration, et cetera. So, you know, we tried to take that seriously, and the bottom line here, it's about a $28,000 system. And that doesn't include the software. This is a software-controlled system with MATLAB and LabVIEW software, but this includes everything except the room itself. It does include the treatment on the walls of the room. So it's within the means of many laboratories and doesn't require a huge investment to be able to implement this test. Where does it stand? The data are now in from several studies. Some of those studies we've talked about, you know, field test initially, lab test thereafter, and some of the data warrants significant concern in my mind about the effects of devices on situation awareness. I think we as hearing conservationists have a responsibility to address this. We have a repeatable, objective, device-sensitive test battery in place. It includes stimulus materials. I mean, they're ready-made. It's computer-controlled. The protocols, counterbalancing, et cetera, and parameter-specific measures. The hardware and audio is configured, and most of it's available off the shelf. And it's largely automated via software control and scoring programs. Obviously, this is a matter of time and convenience, but it's also a matter of repeatability across laboratories because we want to take the experimenter out of the picture as much as possible. And the proof of concept data are in hand. Therefore, you know, we've offered it. You know, it's under military review now, and you know, our hope basically is that in some form it will get used and applied, and not wait too long to do that. Thanks to the Hearing Center of Excellence especially for picking up the flag on this and helping us implement the development of the battery. And just want to close a little bit about the lab. These are the PhD students that have graduated from the Auditory Systems Lab since 1982. And about 2/3 of those have worked on problems in hearing conservation, hearing protectors, auditory signal, et cetera. And you'll recognize some of the names. But one of the things I wanted to mention, I'm just going to single out Colonel Casto because I know her very well. She did her dissertation at Virginia Tech. And, you know, this is the blessing of being a professor that you get to work with students. And all the students that are in blue, by the way, were military folks. And what I want to say about Christie's dissertation, it was about protection of the pilot in the Black Hawk cockpit and providing the ability to communicate and fly the aircraft without too much having to fool with the headset. Very much about a human factors problem relating to our field. And that dissertation went way outside the realm of hearing conservation, communications, into the human factors world, and was reviewed independently. She won the Dissertation of the Year award for the best dissertation in aerospace human factors, and then thereafter, she wrote the paper that won the Haley Award for the best paper in Army aviation for helicopters. So this is, how far-reaching the work that you do can go. Again, I'm sort of different in the sense that my background is human factors and ergonomics, and our discipline recognizes the work that has come out of NHCA, and people like Christy have come from the audiological background. So thank you for your support. If you're interested in any of this, I'll be glad to talk to you. There's a couple of very long slide sets on the website if you're interested in anything else.
Congratulations again to Matt and John, and as John just said, if you're interested in the extended versions of their presentations, you can go to the Safe and Sound website. On behalf of NIOSH, I'd like to thank the National Hearing Conservation Association for our partnership in awarding these. It's a wonderful, wonderful recognition for folks who struggle in this area, sometimes alone and sometimes long hours without much support to bring these wonderful innovations and excellence in audiology to us. So thank you very much. I'm pleased to again see you all, and have a great rest of the meeting.